Hi guys, welcome to lesson 21, which is about 20-1, which is about geometric sequences. This is going to be in your Springboard book from pages 308 to 310. You'll want a pen or a pencil and your calculator. And what we are going to do is determine if a sequence is geometric, so just like we talked about with arithmetic sequences. Then we are going to find the common ratio, so a little bit different than the common difference for arithmetic sequences. And then we're going to write an expression for a geometric sequence and calculate the nth term. So let's go ahead and get started. We're actually going to skip page 307 and most of page 308. And if you could just kind of go down to the bottom of page 308 there. It says a geometric sequence is a sequence in which the ratio of consecutive terms is a constant. The constant is called the common ratio and is denoted by R. So just like with arithmetic sequences, that is when from term to term you are adding or subtracting by a common difference denoted by D. With geometric sequences, we are multiplying or dividing by a common ratio that's denoted by R. Okay. So number 3 says, consider the sequences in item 2b, which we didn't do that part, but here are the 3 sequences. And basically what you're doing is trying to figure out what the common ratio is, or what is being multiplied or divided each time. So it says here, if the sequence is increasing, then R is a whole number. So that means it's going to be multiplying by a whole number. But if the sequence is decreasing, then R is a fraction, because what that means is you're basically multiplying by a fraction, which is the same thing as dividing. Okay, so in this first one, the common ratio, so it goes from 16 to 8 to 4 to 2. So basically you can think of it as we are dividing by 2 each time. 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2, and so on and so forth. But really what you're doing is you're multiplying by 1/2. So if you cut 16 in half, you get 8. If you cut 8 in half, you get 4. So your R is going to be 1/2. Your common ratio is 1/2. Okay. Then here we can see, okay, to get from 2 to 4, we're multiplying by 2, multiplying by 2, multiplying by 2. So the R for this one is going to be 2. And then this next one, you got to be careful here. Again, it's decreasing, so we know we're going to have a fraction. But what you can do, and if you look at this little math tip over here, it says to find the common difference in an arithmetic sequence, subtract the preceding term from the following term. To find the common ratio in a geometric sequence, divide any term by the preceding term. So what you could do here is technically 64 divided by its preceding term, which is 256. So you could do that, and when you simplify that, you're going to get 0.25 or 1/4. Okay, and same idea, if you did 16 divided by 64, or 4 divided by 16, or 1 divided by 4, you would get 1/4. So that means it's basically like you're dividing by 4 each time, or multiplying by 1/4. So these would be the R values, or the common ratios, of those 3 sequences, geometric sequences. Okay. So let's keep moving here. So basically number 4 here on page 309 says use a sub n and a sub n minus 1 to write a general expression for the common ratio R. Well, what I just said is if you have terms, so like in that last one, or in any of them really, so we had 2, 4, 8, 16. 2, 4, 8, 16. And what you could do if this is your a sub 1, and this is your a sub 2, a sub 3 meaning first term, second term, third term, and fourth term, you can literally just start dividing. So a sub 2 divided by a sub 1. Okay, well that would be 4 divided by 2, and that's going to give you 2. And then do that again. Do a sub 3 divided by a sub 2. Whoops. And so that would be 8 divided by 4. 8 divided by 4 is 2. So that's how you can get your common ratio. So basically what you are doing is taking a certain term and dividing it by the term in front of it. So we're going to call that a sub n minus 1. So if you took, a sub 4 and divided by a sub 4 minus 1 or a sub 3, then you're going to find your common ratio. Okay, so that's a little helpful hint there. All right. So what I want you guys to do here is try to pause the video and come up with, do number 6. So come up with A, B, C, and D. It's asking you to determine whether each sequence is arithmetic, geometric, or neither. And then if it is arithmetic, you want to state the common difference, which is what we were doing last week. And then if it is geometric, you want to state the common ratio. Okay, so pause the video. All right, and hopefully you guys did that and you got A is geometric, B is geometric, C is neither. And then, try that again. And then D is arithmetic. So that's what you should have gotten. So A is geometric because it is multiplying by 3 each time. So the common ratio is 3. B is actually also geometric, but what they're multiplying by, and as soon as you see those alternating signs, so a positive, a positive, a negative, you know your common ratio is probably going to be negative. And then what they're multiplying by is negative 2. 1 times negative 2 is negative 2. Negative 2 times negative 2 is 4, and so on and so forth. Okay. Part C is a neither because, as you can see, they add 5, and then they add 7, and then they add 9. So they're adding by odd numbers, but it's not a constant number. It's changing each time. So that's why it's neither. And then part D is going to be arithmetic, and that is because they are subtracting 5 each time. So D equals negative 5. Your common difference is negative 5. Okay. So hopefully you did pretty well on those. And then we're going to move to the next page here. And on this page, it says the terms in a geometric sequence also can be written as the product of the first term and a power of the common ratio. So now we're going to go ahead and come up with the formula here. So it says for the geometric sequence 4, 8, 16, 32, 64, identify the a sub 1 and the r. So first of all, remember your a sub 1 is just the first term, so that's 4. And your r is going to be your common ratio. So what are they multiplying or dividing by here? And it looks like they are multiplying by 2 each time, so our common ratio is 2. So then if you go ahead to figure out a sub 2, you would do 4 times 2 to the first power and get 8. If you if you try to find the third term, you would do 4 times 2 to the second power and get 16. Try to find the fourth term, 4 times 2 to the third power. So each time, what you're doing is you are taking, in this first spot here, all of these are going to be your a sub 1. So that's what comes first in your formula, your a sub 1. Then all of these are being multiplied by your common ratio, r. And then if you look at, let me go ahead and erase this now. If you look at your exponent here, it's being raised to the power of whatever term you're looking for minus 1. So that's where this n minus 1 comes from. Okay. So this is your new formula, and I want you guys to go ahead and write that down. This is your explicit formula, okay? And it is a sub n equals a sub 1, so your first term, times r, the common ratio, to the power of n minus 1. Okay, so again, make sure you jot that down. We're going to go ahead and use that in the next two examples here on page 310. So 12a, it's asking us to find a sub 16. So that's the first thing here. We want to find a sub 16. And we're going to use this formula here. And so we need what our a sub 1 is. So our first term is 1. And then we also need what our r is, or our common ratio. And our common ratio, so 1 to 2, they're multiplying by 2. 2 to 4 multiplying by 2, and so on and so forth. So our common ratio is 2. So we're going to plug this all into, again, this formula here. So we have a sub 16 equals a sub 1, which is 1, times, so this has a little dot as the times. I sometimes like to do parentheses, but either way. And then the common ratio is 2. And then just remember you're doing whatever this number is, but minus 1. So 16 minus 1 is going to be 15. So then you would plug that into your calculator. 1 times 2 to the 15th. And in your calculator, I would use those parentheses. And you're going to get a pretty big number. You're going to get 32,768. Okay. And these numbers, especially when we are looking for a term like 16, these are going to get a little bit larger because we are multiplying. So since we are multiplying by 2 each time, the numbers are going to get pretty big pretty quickly. Okay. All right, or pretty small if we are multiplying by a fraction. Okay, so let's look at one like that. So again, we're going to use the same formula. So let's first find our a sub 1, which is, in this case, 4,096. And then our common ratio, these numbers are getting smaller. So again, we know it's going to be a fraction. So what are they getting smaller by? Well, if we keep dividing by 4, that's what's happening. So the common ratio here is 1/4. So now let's go ahead and plug this in. We're looking for a sub 9, the 9th term. So we are going to do 4,096, which is your first term, times your common ratio, which is 1/4, to the n minus 1, which n again is 9, so that's going to be to the 8th. So again, you can plug that into your calculator, and you will probably get a decimal, but if you change that decimal to a fraction, it would be 1/16. Or if you did write it as the decimal, that wouldn't be wrong, but it's 0.0625. So either one of those would be okay. Okay. And that's it. So that's how we use the formula. We're going to do more practice with this tomorrow in class. So please, if you have any questions, bring them to class tomorrow. Other than that, have a good one. Bye-bye.